Welcome, fellow mathematicians, back to Crack Course. I'm Talia Milos.
And I'm Shane Howard. Last week we did Chapter 1, which dived headfirst into bear fighting and bicycle maintenance. Now this week we're going to be diving into the magical, complex world of differentiation.
Let's get right into it. Differentiation is the process through which we can calculate the instantaneous rate of change at any given point on a continuous interval of a function. In simple terms, the derivative is the slope of the tangent line to any single point on a function.
Created and streamlined through a combined effort of Sir Isaac Newton and Gottfried Leibniz, differentiation was introduced in the late 17th century as a wave of new techniques in analytical geometry and symbolic algebra took over the forefront of mathematics.
While Isaac Newton was originally credited with the invention of differential calculus, it was bulky and intensely complicated. Imagine riding a bike with square wheels. You could do it, it's just going to take you a long time to go ultimately not very far. So to find a way through that complicated mess of mathematics, Gottfried Leibniz worked a way out of that process through a series of new rules.
Leibniz's rules are widely used across the world today and will be the main focus of this video, where we will be covering his quotient rule and product rule, as well as dipping our toes into Sir Isaac Newton's rules of implicit differentiation.
The product rule is the method through which we can differentiate equations that have two terms containing variables multiplied with one another. The formula for this process, shown by the derivative of f of x times g of x, is solved through multiplying the first derivative of f of x by the initial g of x function, and adding the first derivative of g of x multiplied by the f of x function. To show an example of this method, we will take the derivative of the equation x squared times x plus 4, using x squared as our f of x function and x plus 4 as our g of x function. We first take the derivative of x squared using the chain rule, which gives us 2x, and multiply it by our g of x, x plus 4, and then add the x squared multiplied by the derivative of g of x, which will give us 1. We then can simplify the equation to reach the final differentiated solution, which is 3x squared plus 8x.
Our second rule is the quotient rule, which deals with the problem that arises when we want to take a derivative of functions that are being divided. With our standard assortment being f of x divided by g of x, the formula for solving these problems is g of x multiplied by the derivative of f of x minus f of x multiplied by the derivative of g of x, all divided by g of x squared. Simply put, we can say low derivative of the high minus high derivative of the low divided by the low squared. With our example problem being 2x cubed divided by 3x plus 2, our first step would be to take our g of x function of 3x plus 2 and multiply it by the derivative of our f of x function, which results in 6x squared. This is then subtracted by our original f of x function, which was 2x cubed, and multiplied by the derivative of our g of x function, which equals 3. This is then all divided by 3x plus 2 squared. We then simplify the top by distributing 6x squared to our original g of x function and subtracting that by the value we get from multiplying 2x cubed and 3. Our final step is to multiply the bottom function, which results in a final answer of 12x cubed plus 12x squared divided by 9x squared plus 12x plus 4.
Next, we have implicit differentiation. The first step to implicit differentiation is to differentiate both sides of the equation with respect to x. The second step is to collect all terms with that dy dx to one side of the equation. Next, factor that dy dx out of the side of the equation. And finally, solve for dy dx.
For our example problem, we have x squared plus x times y minus y squared equals 2. Our first step is to take the derivative of x squared, resulting in 2x. We then use the product rule to differentiate x times y, with the result coming out to be x times dy dx plus y times 1. Next, we take the derivative of negative y squared, resulting in negative 2y dy dx. And finally, we take the derivative of the other side, resulting in 0. From here, we rewrite the problem so it's easier to visualize and move everything without a dy dx to the other side of the problem. With our new problem of x dy dx minus 2y dy dx equals negative 2x minus y, we factor out the dy dx from the left side of the equation and divide what remains over to the other side, which results in dy dx equaling negative 2x minus y over x minus 2y.
And that's it for today's lesson.
What have we covered today? First, we learned about two dueling mathematicians, Sir Isaac Newton and Gottfried Leibniz. We've mastered product rule and quotient rule, as well as tried our hand with implicit differentiation. Thank you for learning with us today, but before we go, this show would not be possible without the help of all the people behind the scenes and everyone here with us at Crap Course Studios.
Thank you for watching, and we'll see you next time.